Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover section 3.1 and 3.2. There we go. So 3.1 is the quadratic function. And when you're working with the quadratic function, the degree is 2. By degree, what that means is the largest exponent. So like this one, the largest exponent is a 1. So the degree of this is 1, and this is a linear function or a straight line. The largest exponent in this polynomial is 2. So this is degree 2, and it's a parabola, or it's also called the quadratic function. And the last one that I'm showing you here at least is degree 3, which is a cubic function, which we'll get into later. But this section is quadratic functions degree 2, and they are parabolas. We will be using them with revenue, cost, and profit for the most part. When you do have the quadratic, you can write it in this form with your squared term first, then your x, and then your constant. And a is the leading coefficient, but also when a is positive, your graph goes up. When a is negative, the graph goes down. And this point is called the vertex. Notice when it's going up, it's the lowest point on the graph, so it's the minimum. And when it's going down, it's the highest point on the graph, and so it's a maximum. When it's in this form, to find the vertex, we use the x equals negative b over 2a. And to find the y value, you plug that answer into the equation, and that'll give you your y value. So if we look at an example and we want to graph this, first thing we want to find is the vertex. Negative b over 2a. Well, we use a, b, and c. So b is a negative 12. Negative times a negative 12 over 2 times a, which was 3. Gives us 6. Positive 12 divided by 6 is 2. So our x value for our vertex is 2. To find the y value, you plug it back into the equation. And if we plug that into our calculator, 3 times 4 minus 24 plus 9, we get negative 3. So our vertex is 2, negative 3, over 2 and down 3. And then we know it's going up. Since it's going up, we will have 2 x-intercepts. To find them, we need to factor it. So when we're finding the x-intercepts, we're setting it equal to 0, because you find your x-intercepts by letting y equal 0. So when we plug in the 0, we could factor a 3 out first or divide everything by 3. And we have x squared minus 4x plus 3. So we want two numbers that when we multiply, we get 3, that when we add, we get a negative 4. Let's see, well, 1 and 3. When we multiply, we get 3, but when we add, we get a positive 4. Well, we can make them both negative, because when we multiply them, we still get the positive 3, and when we add them, we get the negative 4. So this will factor into x minus 1 and x minus 3. And then we set each of those equal to 0 and solve. So our intercepts for the x are at 1 and 3. The y-intercept is nice for a polynomial because it's the constant. When you're finding the y-intercept, you're letting x be 0. When I let it be 0, we have 3 times 0 squared minus 12 times 0 plus 9. Well, these drop out and leave 9. So it's going to hit the y-axis at 9. And then that would be our graph. Let's try another one. Okay, this one, a parabola. The negative means the parabola is going to go down. So we find our vertex. X equals a negative b, so b is 4, comes from here. A would be negative 1, b is 4, c is 5. So negative b over 2 times a, which is a negative 1. Negative and negative is a positive. 4 divided by 2 is a 2. To find the y value, we plug that in. And then we calculate it. We have a negative 4 plus 8 plus 5. 9. So our vertex is 2, 9. And over 2, up 9, and then it's going to come down. Let's do the x-intercept. We just set the function equal to 0. So we have negative x squared plus 4x plus 5 equals 0. Now you could multiply it through by a negative so that it's easier to factor if your first term is positive. So we want two numbers that when we multiply we get negative 5, that when we add we get negative 4. And those would be 1 and 5. In order to make it negative, we need one of these to be negative. If we make the 5 negative, when we multiply them, we get a negative 5, and when we add them, we get the negative 4. So it's x plus 1 and x minus 5. Set each equal to 0. And solve. So 5 and negative 1. Last thing is the y-intercept. Plug 0 in for x. This drops out, and leaves 5. Let's see. 2, 4, 5 will be here. And then we just draw our line. Try one more. This one is in standard form that we're going to look at. When it's in standard form, A is still out front. It's factored out of the quantity though. And then you have H and K. H, when we find the vertex, is the opposite sign, and K is the same sign. Let's notice this is a minus, so when we pull it out, it becomes positive. So in this one then, our vertex is negative 2, negative 4. So we go -2 and down 1, 2, 3, 4. And we're here. Now this is positive in front, so it's going to go up. So we can graph and have an estimate. They also call it shifting because this moves opposite of the sign, so we're going to move left 2, down 4. And this one, right or left opposite of the sign, so it's going to move right 1, up or down, same as the sign, down 5. So it's getting you ready for shifting. But if we use the vertex, the X comes with the part that's with the X, but it's the opposite sign, so it's 1. And this one is the same sign, so it's a -5. This negative out here, that means it's flipping on the x-axis. So instead of going up, it's going to go down like this one did. So 1, -5. Oh, maybe I'm going down. One, 2, 3, 4, 5. So we go over 1 and down 5. And then because of this negative, it's going to go downward. Notice there's no x-intercept. So in some cases, there isn't an x-intercept. If you're told to find any x-intercepts, look at what your parabola is going to do first to see if there are any before you start looking for them. And that's why when I put my vertex, I thought about how it was going to go to see if I was going to have them. Okay. I'm going to do a few problems from the book. Number 57. It's down here. Can you see 57? Yeah. So number 57 says, the profit for a certain brand of MP3 players can be described by this function, 40x minus 3000 minus 0.01 x squared dollars, where x is the number of MP3 players produced and sold. To maximize profit, how many MP3 players must be produced and sold, and what is the maximum profit? So let's look at our equation. And you can access your book on my math lab if you don't have the book, the hard copy of the book, but it's on page 179. And our profit function is this. They want us to find the amount, the maximum profit, and the quantity that gets us it. Well, let's think about the graph. The degree is 2, so it's a parabola, it's quadratic. The x squared term is a negative, so this parabola is going down. Since it is going this way, notice that our vertex is our maximum. So if we want to find the maximum, we have to find the vertex. The x value is a -b over 2a. Now these are out of order. Remember, a is always the squared term, so it's the -100th, and b is 40, and c is the -3000. So these were not in order. Be careful of that. I'm going to work downward. negative B. Negative 40 over 2 times 0.01, and it's a negative 0.01. So negative and negative is a positive. 40 divided by 0.02 equals 2,000. Now, profit it said was dollars, and X it said was number of MP3 players. Well, this is X. So 2,000 MP3 players is what will give us a maximum profit. To find that maximum profit, we have to plug it back in. Let me just plug it in. 40 times 2,000 minus 3,000 minus 0.01 times 2,000 squared. $37,000, and it said it was in dollars. So 2,000 MP3 players give a maximum profit of $37,000. $58 starts down here. The profit for easy cut lawnmowers can be described by the function. And the function is in dollars, and X is the number of mowers produced and sold. Find out how many will give us a maximum profit and what the maximum profit is. So we have P of X equals 840X minus 75.6 minus 0.4 or 4/10 X squared. This is in dollars again, and X was how many, or the number of mowers produced and sold. They want us to find the maximum. Well, this is a parabola because it's squared, and the squared term is negative, so it is a parabola that's going down, so we can find a maximum, and it will be the vertex. So X is a negative B over 2A. I'm going to plug that in. B is the 840 over 2 times A plug that in. Negative and negative is a positive. 840 divided by 0.8. So X was mowers. 1,050 mowers will give the maximum profit. We need to find it. To find it, we take the 1,050 and plug it in for P of X. When we plug that in, we get this. And 840 times 1050 minus 75.6 minus 4/10 times 1050 squared. $440,924.40. Not a bad profit. $59 states the annual total revenue for pilot V5 pens is given by this function in dollars, where X is the number of pens sold. Find the maximum revenue and the number of pens that get the maximum revenue. So our function notice there's not a C. When there's no C, C would be 0. So if there's ever a B or a C missing, it's 0. If this term is missing, then it's linear, it's not quadratic. So again, it is a parabola, and it will be going down because it's negative. So we can find a maximum. Vertex is negative B over 2A. Putting in the negative, B is 1500 over 2 times A is the negative 0.02. We get 1500 divided by 0.04, 37,500. And that was pens. So 37,500 pens give a maximum profit of, oh no, this one wasn't profit, this was revenue. Maximum revenue. Let me just plug it in. Equals 1500 times 37,500 minus 0.02 times 37,500 squared. We plug that in our calculator. Some nice revenue. 28125 and 3 zeros. $28,125,000. So that's everything in 3.1.